Hello, Eigen Chads and Eigen Stacy's. Welcome back, guys, to another episode. Make sure you like, share, comment, subscribe if you haven't done so already. Check us out at Eigenbros.com, Eigenbros on Instagram, Eigenbros on Twitter, Eigenbros2 on TikTok, and patrons. Guys, we love you. Thank you so much for all your support. You guys continue to support. We had a successful patron hangout the other day, which we'll be doing more of those in the future. So if you guys want to support your boys, donate to the Patreon if you like us enough. You can hang out with us for a little bit, every week. We'll see
30
about
minutes
the
to an hour.
time. Yeah, we're still trying to figure it out. And also you get a guaranteed at least 30-minute audio podcast every week. So if that's incentive, check out the Patreon, guys. And
or more.
We think you'll like it. Yeah.
Or more,
right.
As I like to, now put as an asterisk.
Yeah. We're always trying to think of some new things. So.
Yeah.
But anyway.
But today,
I was trying to give you some time to eat one, but I think I might have flown through the intro.
Yeah, I know. No,
Juan's a busy man today. We kind of had a little bit of a, we're pushing this out.
Daylight savings. Why is daylight savings time a thing still?
I don't know, man.
It really should be done away with. It's one of these.
You think?
100%. I know the title of the video says how to be basically a good physicist.
Mm-hmm. In more or less words.
More or less words. Might be clickbaity, might not be. We
don't know yet.
But if you're here for that, please stay tuned. But I want to rage on daylight savings time.
Really? You got a bone to pick, huh?
Rage on the dying of the light. What is it? What is that?
The dying of the light?
What is that called? That quote by who is that? Who's that poet?
Oh, I don't know. Edgar Allan Poe or something?
Don't go quiet. Something. Yeah, is it Edgar Allan Poe?
I don't know, but it sounds very emo and Edgar Allan Poe-like to me.
Yeah, do not go gentle into that night. Into that good night. It's Dylan Thomas. Oh, Dylan Thomas.
I was just thinking of The Light That Blinds, that song on Guitar Hero 2. Yeah, but anyway.
Well, this one is the quote goes, "Do not go gentle into that good night. Old age should burn and rave at the close of day. Rage against the dying of the light." And that's how I feel about daylight savings time.
It's very impassioned, one.
Rage against the dying of the light because, bro, we're losing good daylight hours to the morning.
True. Well, you can take that up with whoever that may be, Uncle Sam, or I don't know.
Uncle Sam. It was. I think it was made during.
Or the farmers.
Yeah,
of America.
for war effort. Do you know why?
I don't know. I just heard it was like to get the farmers synchronized or something. I guess for the roosters. I don't know.
Because we're the only country that does it. I think.
Really?
One of the bigger countries, yeah.
Oh, okay. I don't know.
It's silly.
Anyway. Well, let's get to the topic because we only got 15 minutes to capture our audience, okay?
Thank you.
So basically, guys, we want to just give some, some tips on how to be a good physicist and what makes a good physicist, I guess. Kind of expound upon that. I guess to start one, let's just say, what do you think makes a good physicist? Just jump right in.
Coffee.
I don't know if I would agree. I think the chattest of physicists use no coffee, is what I'm saying.
Oh, okay. That's a bold claim.
Yeah, I'll say it.
No, I think there's a good resource out there. I don't know who the professor is, but if you Google how to become a good physicist, good theoretical physicist, he has like a source, like sources that are all free.
I think I might have seen this back in the day, and he was like, I worked abnormally hard as a physicist.
Really?
Or maybe this is different. I don't know. I read something back when I was an undergraduate, just starting off, and there was this guy's website that was telling you how to be a good physicist and what you need to do. Basically, it was just like study every problem in the universe. And
what the hell? No.
I was like, damn. I was like, it makes sense, but.
This guy, no, it's about, this one's by Gerard Tuft.
Tuft, okay.
Tuft?
This might have been him.
Oh, yeah, he's got some really graceful eyebrows, let me just say.
And wow, what a good website.
Yeah, it's actually pretty good for a physicist. It's not HTML.
No, it was.
Yeah.
I was being sarcastic.
Oh, okay. How to become a
It
good...
looks okay, but yeah.
But he says it's under construction for young students.
And has a picture there from 50 years ago.
His only headshot.
30 years ago.
Every physicist to have one good headshot.
Right. It never changes.
So yeah, he earned a Gerard to Hooft. He earned a Nobel Prize.
Yeah.
And he didn't have the internet, so he's
doubly Chad.
Yeah. So this is the original. He's the original physics Chad.
Yeah.
If you think about it, he said you won't get your Nobel Prize for free, and remember, all of this together takes our students at least 5 years of intense study. And at least one reader was surprised at the statement, saying that she would never, or he would never, master this in 5 years. Indeed, I'm addressing people who plan to spend most of their time to this study. More than rudimentary intelligence is assumed to be present, because ordinary students can master this material only when assisted by patient teachers. It is necessary to do exercises. So, yeah. He's saying, and what he what he suggests is the following: primary mathematics. So that's like basic level stuff that we all know, you know. Real numbers, Fourier transformations, complex plane. He says using the gamma function.
Okay, what is that?
Would you agree with that?
Like he's saying to know how to use it.
I'm going to say if you can agree with what he's saying here.
But what is he saying? I don't know.
To become a good theoretical physicist, you got to learn all this shit, and I'll just go through the list. Here.
Oh, this is the math section.
Yeah, he's saying this is where you
why
start.
is it all like math functions?
This is where you start. Yeah.
Okay.
He's like, you got to know the natural numbers.
Okay.
Integers.
I think that's covered.
Yeah. So basically, basic math, complex numbers, set theory, which I don't necessarily. Well, I guess, like, would you agree with that, set theory?
I think it's depending on how high level you're trying to go, because set theory kind of, it's that big one that kind of gives you a massive advantage with symmetries and whatnot.
Yeah, and it says topology.
Yeah, I think it helps. I don't think it's mandatory, though, especially if you're an experimentalist. Maybe this is more in the theory, theory side.
Yeah, I'll put a little asterisk on things that I think you need for experimental, but
Yeah.
But for this, yeah, it's I mean, this is stuff that you learn besides set theory. I think this is stuff that you learn as an experimentalist anyway. Most of the curricula is built around theory anyway.
Yeah.
Unless
so you're going to be overqualified as an experimentalist already, pretty much, if you're an experimentalist, for sure.
Yeah, because most unless it's explicit, right? Because most explicit programs are applied. Applied physics is pretty much experimental or practically minded.
Right. So I
physics.
guess they'll talk about scanning electron microscopes a little more.
yeah. But how to? Yeah, I mean that's kind of where it starts. But then they get to classical mechanics, which I mean we all know.
He goes down the list.
Yeah, he has a whole look at it. Look at all this. He says and you got to study for 5 years at least.
That sounds legitimate to me. People are shocked by that. I know one of the guys we had on here before, John. You remember him back in the day? It's an old podcast we did. I think it was called like The Origins of the Podcast or something. A little purple thumbnail if you want to check it out. But I remember he was like, he mentioned that he was shocked how much he knew after just undergraduate in physics. He was thinking that you needed graduate school to kind of really be a complete physicist, but it's not really true. I think once you've done an entire undergraduate track, you pretty much have all the tools to be a legitimate, real physicist, I feel like. You just may be a little bit more, less refined with your tools, but I think you definitely have what it takes to become, a full-fledged researcher if you really wanted to.
Yeah, grad school is like it's like, when you beat a video game, it's like New Game Plus.
Yeah.
It's like, you're like, oh.
It's like Diablo Hell mode.
It's like you go into a new game save with your skills that you already have. Because you're retaking the same classes.
Yeah.
And you're just like, oh, shit, the enemies are harder.
Right.
But I still have skills from my
Right, they're all the same enemies, except you just have better weapons, and you have, they have more health bars and what do you call it?
Higher,
like resistances to things.
Yeah.
It's so true.
That's what it is. I don't know what else to put
And
it.
maybe being a professor is really the ultimate hell mode because you're basically teaching the same class now.
Yeah. Yeah, grad professor. I don't know.
It's like hardcore mode.
Yeah, because you have to really be prepared for the hardcore students. They have really good questions.
Yeah.
But that's
Well,
what
you're building the curriculum also from scratch from your own mind.
Yeah, but that's where the syllabus saves you.
Yeah, yeah.
No questions outside the syllabus. No, I'm just kidding. But anyway, like this guy's saying, classical mechanics to be a good Chad or Chadette or whatever. What
Stacy, I thought was the
Stacy
analog
physicist?
to Chad.
I don't know.
I think you told me that.
Really?
Yeah.
Chad and Stacy's?
Yeah.
I
I asked you that, and you were like, Stacy, and it stuck with me.
I must have looked it up at some point. I don't know.
I feel like it's legit because Stacy's mom's got it all going on.
Stacy's mom. Yeah, it's such a good. Yeah.
I feel like it fits.
It does. It does. But he's saying you need to learn static mechanics or statistical mechanics, Newton's laws, orbits, many body problem, which is a 3-body problem essentially.
Sure.
The action principle, Hamilton's equations, Lagrangian. Those
Sounds
are the
legit.
Hamilton's equations and Lagrangian and the action principle. Yes, you all learn in classical mechanics.
Yeah.
And that's the foundation.
If you wanted to ignore everything else on the list, that's pretty much what you would need to know.
Yeah, that's
like all of physics, right?
I mean, that's the bare minimum to me.
Yeah, me too.
Yeah.
Because you're just manipulating energies really at the end of the day.
Yeah.
And finding things from energy.
Yeah, physicists are all about energy.
Yeah. Energy is life.
Yeah. And we don't mean that in a way that's like colloquially used, but 100%.
Also, we kind of do though.
Yeah, also, yeah, I guess. The harmonic oscillator, the pendulum, and he just ends it there. It looks like he wanted to say more about it, but the harmonic oscillator, is just bread and butter.
Mm-hmm.
Almost everything is a harmonic oscillator because in physics there's a lot of periodic motion.
And you'll get that manipulating the Lagrangian and the Hamiltonian anyway too. So that falls under the same umbrella, I feel like. But the harmonic oscillator are very, very useful.
Navier-Stokes equations.
Navier.
Huh? Is that the cream company?
Well, it's French, so I don't know. Could be.
Navier-Stokes equations. I'm trying to remember. Yeah. I think those actually come up a lot.
Really?
Stokes equations.
I've never seen them in my entire
in terms of the concepts?
my entire career.
Really?
Yeah. Navier-Stokes, I've never seen it.
You have.
I haven't.
Oh, okay.
Pretty sure.
What? Okay, well,
I hate fluids too, man. I don't fuck with them.
You're like water.
I don't fuck with turbulent shit. I'm not a fan.
No, come on, man.
Too hard for me.
You know Navier-Stokes.
I've seen the equation later on, but I've never seen it during actual school. When did we ever do Navier-Stokes?
I mean, it's the foundation. You basically use it a lot in E&M. It kind of has the end, like it's sort of like it's basically differential equations.
Okay, I see what you're saying, but it's not. But that would be like magnetohydrodynamic stuff.
Right.
I never messed with that really. That was one of the worst homeworks I did, I think.
But you kind of need that kind of stuff, or at least the understanding of it for E&M.
Yeah, it's probably useful.
But yeah, I mean, if you
take
go
what I say with a grain of salt, because I also have a horrible memory.
Poisson. Thank you,
man. You're killing these French ones,
dude. I'm dying over here.
Poisson means fish, I think, in French.
It does.
Yeah.
Fish brackets. That's a good T-shirt. Fish brackets.
Yeah.
Poisson brackets with fish.
Huh?
A T-shirt. Poisson brackets.
Oh,
it's like fishes.
Yeah, I like it. Merch idea.
Yeah. But Poisson brackets is the anti. Is it the anti-commutator?
Yeah.
Yeah. And that's a concept that kind of gets introduced in classical mechanics that you need to know because the analog or the counter analog. Whoa, the counter analog comes in quantum mechanics. The commutator.
Yeah, which is really important in quantum mechanics. Basically, it's one of the foundational principles for what makes something quantum.
Yeah.
If it has a
a
commutator non-equal to zero. Hugely important in quantum mechanics.
Yeah, let's get into that. So, how much
quantum?
quantum to become
Critical.
a good physicist?
Critical in the modern age. You can't be a modern physicist and not do quantum. Basically, if you stop at quantum, you're an Isaac Newton or something. It's like, I guess you know a lot of stuff in physics, but if you're trying to do modern physics, you need quantum. Unless maybe astronomy. I don't actually. Even then, I think you still kind of need it because they started talking about black holes and quantum mechanics too. So I think even then you're screwed in that front. You can maybe get away with it a little bit more, but you need quantum to be a modern physicist, in my opinion.
And if you're ashamed that you don't get it, take a victory lap for quantum mechanics.
Yeah, there'll be a lot of people taking a lap with you.
Yeah. Look, I'm not ashamed to say it. I had to retake quantum mechanics.
Oh, you had to retake it?
Yeah.
I didn't know you retook it.
I had to retake it because the first time I was like, I'm not happy with this. I was like, I passed the class.
Oh, this is an undergraduate.
Yeah.
Okay.
I was like, I passed the class, but I wasn't happy with my grade.
Yeah.
And I was like, man. And I remember I felt like I learned because you and I are kind of the same vein where it's like we really, okay, like you're taught how to do quantum mechanics, but that's not enough.
Right.
To me, it was like,
But that's a farce when you're thinking it's a trap in quantum mechanics because you're not going to know what you're doing in quantum mechanics because you can't use intuition really. You're building a new intuition, a quantum intuition, which is heavily math based. So if you're an intuitive type person and a very like spatial thinker, just get used to it. Like the idea that you're going to have to switch to a mathematical brain, a very algebraic brain in terms of quantum mechanics, because you can't really build an intuition for those concepts. So you probably retook it and really didn't need to.
Exactly.
Yeah. I've done that many times in my life, and I had to get out of that habit.
Yeah. I mean, it was more, I mean, also helped like my GPA, but like slightly, but it wasn't usually when you were taking classes. Actually, this might have to do with how to be a good physicist.
Yeah.
Try your damnedest the first time to get it right.
Yeah.
Because redoing classes, depending on the way your school does grades, sometimes it erases the previous class grade.
Yeah.
But sometimes it takes the average of the two.
Yeah, I see.
Yeah, so it's like you need to figure out if it's even worth your time to redo it.
Right.
Unless you're really just doing it for yourself, for your own understanding. But in quantum mechanics, it's almost just you kind of have to suck it up. And I wish somebody told me then. It's just like what you were saying.
Yeah.
It's a mathematical framework. You can't really build a physical intuition. You have to take the math as it is because that's the best thing we have.
Yeah.
Yeah.
That's an interesting thoughts you also had on retaking classes. I personally would recommend never retake classes. I think it's overrated now. I used to do it all the time when I was younger, but that was out of insecurity. Kind of in the same vein that you're talking about, where I just thought I didn't know enough, but then when I get in the class, I feel like I know everything already. And it's just building this. I'm like, this is what you're supposed to do after anyway. You're supposed to, and there's this weird phenomenon I have. I don't know if you've experienced this too, Juan. It's like when you're in these math classes and whatnot, you kind of feel like you don't know shit, but as soon as you finish, it's like you realize that you actually know everything, kind of in some sense.
100%.
Yeah, it's like you don't realize until you actually finish it. So you have to kind of keep that perspective. I would always recommend if just to keep moving forward. If you sucked at quantum mechanics, move on to quantum field theory. That's my 2 cents.
It's the learn as you go approach. And once you realize school is like this, it's like, okay, it's kind of liberating because you're just like, oh, yeah, I'm not really – they're expecting you to how to do physics, not necessarily to really kind of understand it.
And if you pass the class, you pass the class for a reason.
Yeah.
So just believe that you passed the class and you were supposed to pass it. Don't get in your head about you don't know anything really. You really did, and just move on to the next step because you will benefit more from doing that than going backwards. You'll go backwards in the future anyway.
Yeah, and this is a presumption that you're not like unless you're at the edge, unless you're an edge case where you're like, man, I'm right at the cusp.
Even then, I would say no.
No,
if you passed, you passed.
No, I'm saying like if you're at the edge of a GPA cut where you're like maybe on academic probation or something.
Oh, I see. When it's like a do or die situation.
Yeah. Do it. Don't put your pride before
Yeah.
like the pot just being ousted from school.
Yeah.
Like, just do it.
True, you do got to play the game first.
Yeah,
in some sense,
because
yeah.
there is a balance. Like, if you do, because I've known students that are really smart that dropped out because their grades sucked, but they learned the material. Shout out, I think, damn, what was his name? I think his name was Jonathan. I don't know if he watches the show, but
Shout out,
Jonathan.
Rip.
Yeah,
Jonathan.
yeah. He buddy in undergrad. He when I remember when he came in, he killed the game because he would study the material in his own time, but he wouldn't really do a lot of the homeworks. But he would really get a good solid foundation.
Yeah.
And then just not do well
Produce,
in terms of grade work.
Right.
And it was
Gotta
almost
produce.
Yeah, and it was almost like an extension of like that was like, man, this is kind of like he's got the high school way of doing things.
Yeah. You can't adopt that in college. It's over at that point.
Yeah.
You can't just be really smart and study for tests and then not do homeworks. Like, it's kind of flipped in college. You gotta really fucking do homeworks and understand the homeworks, and then the tests are kind of secondary.
Yeah.
And that gets especially true in graduate school. Well, actually, gets graduate schools like everything kind of matters.
Yeah, the grades are usually almost on par. I mean, the homework is on par with tests.
Yeah.
But anyway, yeah. Focus on that. The grades. I think that's a good distinction of how to navigate the two.
Anyway, we should also try to think about less academic life too, because this is how to be a good physicist in general. And people who aren't in school can also be that.
Skip optics.
Yeah. Well, yeah. Let's be real. Skip optics. I mean, it's not unless you're an optics specialist or someone trying to go into optics. Just learn a couple ray diagrams.
Yeah. Do you agree with Gerard here? He says learn optics.
Oh, he says learn optics. I would say you learn the bare minimum of optics because you can kind of already get it once you just understand converging and diverging lenses and know how to draw the ray diagrams. I mean, because what else is there? Like the fucking Fresnel equation.
Yeah.
I mean, and maybe like the index of refractions. I mean, I guess it helps your intuition, but it's very, very minimal.
I think I'm of the opinion that optics should be condensed into a wave mechanics class.
I could see that.
Yeah.
Like spend like a week on optics probably is sufficient. I feel like.
Yeah, I mean, as a case study or something.
Okay.
You know what I mean? Like maybe you spend like you're saying a week or two.
Yeah, I think it's just good to have the optics intuition because you need to know how light bounces off of surfaces, reflective surfaces, or transmits through things. That's very critical because you have to actually think that does translate to a lot of stuff. Like even think about like quantum mechanics and like transmitting waves and things.
Stuff.
So if you at least know optics, you have an intuition for how light moves and how waves move on surfaces.
Yeah.
But it's like you can get all of that in probably a week.
And you will revisit most of that in quantum anyway.
I actually took a whole class on optics, and it was
Me too.
pretty much a massive waste of time.
Same.
I was like, bro, this is literally the same shit I learned in baby physics, and I just wasted all this time taking this class.
Yeah, it felt like I was revisiting the 1800s with my popper hat or something, whatever it's called. Yeah,
beret.
Because I mean, you're learning a lot of the stuff that people discovered in the 1800s, like Doppler effect. You kind of learn, like Terrence, you were saying, the lenses, the different types of lenses that lend to the optical properties. You kind of understand how you get these optical properties from lenses, which is like, to me, it just seems like an extreme case study of how light interacts with this particular type of matter. It's weird, right?
Well, it's like just showing you it's like trying to understand the path that light takes on reflective surfaces or how it transmits and then, index refractions. That's all useful, but it can be condensed very easily.
Yeah, 100%. But the next one is StatMech, statistical mechanics.
Pretty critical.
Some people say that it's StatMech and thermodynamics are two different subjects.
Yeah. But I've always combined them. In my school, we combined them.
No, we separated them in my school, but but I think because the thermodynamics one was more I think more for chemists or something. I can't remember exactly. There was like
Specific heats
scientists
and
that wanted
whatnot.
to scientists that wanted to learn this, I guess, without the heavy rigor of the math.
Yeah,
Yeah.
I get that, honestly.
Right. So
I think you can definitely combine them. For me, they seem very natural to combine.
for physicists, though, you want to stick to statistical mechanics. You'll get to thermodynamics from the stat mech.
Yeah.
Yeah.
But if they're combined, then that's even better. Just two birds, one stone.
Yes, because that you will learn the first, second, and third laws of thermodynamics.
Which I still do not internalize.
Yeah,
I know
the only one
Newton's
you entropy is the only one you know is the entropy one, probably.
Yeah.
And I actually don't remember what number it is. I think it's maybe the second.
I think it's the second one.
Yeah.
Yeah.
And then I think maybe the 0th law where objects are in equilibrium or something that touch each other. I don't know. I can't remember the thermal laws don't stick in my brain for some reason like Newton's does.
Yeah. I mean, because they pummel it into you with Newton. Yeah, I mean, you need to learn those. You need to learn those three, and then you need to learn the Boltzmann distribution.
That's within the realm of statistical mechanics. Yep.
Carnot cycle, the engine stuff.
Mm-hmm.
Yeah. I mean, you see that in university physics, right? Like,
Yeah.
Yeah. You're kind of introduced to these topics anyway.
Maybe not as heavy as like an engineer, maybe.
Nah, probably not. Phase transitions.
Yep.
That's huge. Icing model.
Yeah, classic.
Yeah. And then I guess that's where I don't know.
What about Bose distribution? You need that too.
Yeah, true.
I feel like.
Gerard.
Wonder why he left that off.
I don't know. Maybe he doesn't like Bose. You heard it here first. Exclusive. Electromagnetism. I mean, come on. That's that's one of the. You need to know this like the back of your hand.
Yeah. Pretty much on that list, just put Maxwell's equations.
Maxwell's equations plus Lorentz law,
Wrap it
Lorentz
up.
force, and you're done.
Yeah, and then there you go.
You're done.
At least that's what some of our professor might say.
Yeah. Everything else is trivial.
Right.
Um,
But what does he have?
no, I mean Maxwell's laws in mediums, boundaries, solving the equations in vacuum and homogeneous mediums.
So I guess what he means by boundaries and everything is like the boundary conditions. You know, is that what he's saying? Do you think?
Yeah.
Like Dirichlet and
I guess this kind of falls in the math realm a little bit.
well, even though we already covered that, but like Dirichlet boundary conditions, the von Neumann boundary conditions. I mean, those are applied to every kind of differential equation in physics. So that's very general and extremely
Yeah.
useful to know.
Yeah. He's also saying it's extremely important. He emphasizes
for sure.
this, the vector potential and gauge invariance
Oh.
concepts
Yeah.
that you're introduced to.
Yeah.
Gauge theory is the first instance. Well, I got my first instance of gauge theory in electrodynamics.
Yeah, Griffiths,
Yeah.
chapter 10, 11?
Well,
I don't
I'm
remember.
not that.
It's one of those chapters that like you're like he kind of just throws, hey, you're going to talk about gauges. And I remember trying to wrap my head around it, like, what the hell is he talking about? Because he just kind of throws you to the wolves a little bit, and he's like, I'm going to show you what the gauge does instead of tell you what it does.
Right.
And then he shows you, and it's like a cool trick. It's like a magic trick. I'm like, oh,
Yeah.
cool.
Yeah.
Didn't really tell me
liked
how it worked,
yeah.
though.
I mean, you could kind of see it though. It's just like you're basically manipulating the math in such a way to get what you want out of it, kind of. That doesn't make sense. It's kind of. I mean, it's like you have to kind of see it
To believe it.
right.
It is.
But yeah, it's just math tricks.
He's trying to describe it to someone. It's like, oh,
Right.
gay. I mean, that happened on I
Joe
remember when
Rogan.
Joe Rogan
Yeah,
show.
yeah. Yeah, I'm like, why are they trying to tell Rogan gauge theory? It's kind of useless if you don't care about the math, in my
Yeah.
opinion, because it's literally just like a math instruction kind of.
Yeah.
It's not like one of these good podcast subjects, at least not for a normal podcast. You know, maybe our podcast would be good, but
Sure.
you know, it's not really good for a Rogan podcast when you don't want to talk about math, right?
Right.
So gauge theory is kind of useless if you're a conceptual person.
No, not a conceptual person. You mean?
No, if you are a conceptual person.
What do you mean? How?
Because I'm making the distinction between conceptual knowledge and mathematical knowledge.
Oh, I see. Okay.
You see, so gauge theory is useful if you're into the mathematical knowledge. If you're into just the conceptual knowledge, it's not very useful.
Gotcha.
It doesn't really provide that much insight.
Yeah, because I mean, you're gonna gauge. Learning about gauge invariance is kind of like this interesting property that comes up later in higher level physics. If you really want to learn to the
Supremely
level,
useful.
yeah,
It's definitely Chad tier for sure.
It is.
And it goes deep.
yeah,
Yeah.
yeah. So, so moving on from that, you also have solid state physics.
I took that twice, actually. Once with you, and then once in my undergraduate.
Yeah,
That was another one of those regrettable courses for me a little bit, where I'm like, I kind of didn't learn anything new.
and the electives because it's building on quantum mechanics.
Well, I mean, it was also almost identical. The knowledge I got from my undergraduate version was almost identical to what I got in the graduate version. So I felt like it was a little bit of a waste of time. I probably learned like maybe 5% more than I did in undergraduate, but I mean, I took it.
Yeah,
The most important thing I learned from that probably was just the crystallography stuff. You know,
right.
body-centered, face-centered cubic structures, and how the lattice structure actually, is in solid materials and
Yeah,
whatnot.
same. I actually, I finally understood how people doing X-ray diffraction
Right.
get those planes.
Right.
And you see it in the math, and you're like, oh, that constant, what is it called? The construction factor. It's all,
Oh, wow,
It's all
yeah.
buried in that.
You're bringing back
War
Things I
stories.
haven't thought about in a while.
War stories that I've wiped out of
Right.
my brain.
and then the whole concept of like case-based and how it could become useful and
Yeah,
in,
yeah. It's,
condensed matter.
it's
It's
really
kinda
cool.
interesting.
It's really cool stuff. But I would say if you want to be a good physicist, I mean that's more of if you're an experimental physicist, you're probably just gonna be like, like it depends on the physicist that you are. But solid state
Yeah.
is good
and that's
for
almost,
practicalness.
yeah, but it's almost useless too for people who are like nuclear. It's getting
No.
specialized now.
No, because nuclear actually they need to build detectors and stuff.
Yeah, but do you
They need
need
solid
solid state
state.
for that? Really?
I think you do.
Do you?
I think you do.
You think?
Yeah, because you need to learn how that stuff, I guess how that comes about, like interactions with atoms interact with each other.
I guess. I feel like a course in electronics would be way more useful.
I mean, that's what he says too. He's like, you should probably take a course in electronics. but-
Yeah.
I think that's going to serve you much better than in solid state, honestly. I think solid state, if you're trying to go more theoretical, electronics, if you're trying to go more practical.
And then nuclear physics. This is definitely getting now you're getting into electives.
Yeah.
So take this with a grain of salt. This is what Gerard Tahouf says.
Right.
But from us, I think the bare minimum is the core.
Yeah, we kind of passed
Yeah.
the minimum requirements, I believe.
The
now,
core
right?
curriculum is enough.
Well, I guess we haven't fully.
Because like
we do quantum
oh,
field
actually,
theory and all
let me add one more to the core curriculum.
Yeah.
General relativity.
Yeah, I think.
They skip that a lot, though, it seems, nowadays. But I'm like,
Why?
Well, I don't know, man.
I feel like relativity is like, you got to know relativity.
I
you
know,
like,
but I think it's because they're like, we think it's wrong, but
well, I think they're thinking that you're gonna get it. You're gonna kind of get it in all these different pieces of what you're already doing. Because relativity is kind of, I mean, when you're going high level anyway, you're gonna have to learn relativity all the time. Like you learn it in electrodynamics somewhat. You know, you learn it in quantum field theory. You know, anytime things are going fast, you're gonna jump into relativity eventually. So maybe a whole course isn't as necessary, I guess, because they're thinking that you're going to get it anyway.
yeah,
But I loved relativity. I actually learned a lot in that class.
same. Despite the fact that we had a not so great professor.
Yeah.
We weren't too keen on him, let's say.
Yeah.
He's a good guy, but fuck him.
No, I'm just
You know,
joking.
back in the old
That's
days.
harsh.
Back in the old days, He would be stuffed into a locker if we had our way with him.
Yeah, if I had a bar of soap and and a what do you call it,
A bag of
pillow
oranges, or a bag of oranges, maybe.
like we had to go Full Metal Jacket style on him.
Yeah.
Anyway,
No, but yeah, he. I mean, like you need to make sure that you. I think you need to learn GR.
I think it's highly useful.
GR is such a useful math. You get a lot of useful math, and the concepts there are translate to other subjects where you do end up using like tensor products and summation. What is it like? Clebsch-Gordon kind of. Not Clebsch-Gordon. Sorry. What is the word? What is it? Damn it. The convention I'm talking about with the
Christoffel?
Yeah, Christoffel symbols. Yeah, and then just like the summation and contraction of math operations through the symbols is really nice, and you will see
you get a nice little foray with that stuff and a little familiarity with tensors. I was always insecure about tensors, still am, but that
you
one
at least
you
know
kind
how to use them now, somewhat.
Somewhat. I still don't feel great. I still don't know what the hell the difference between a contravariant and a covariant tensor is. But anyway, that's besides the point. What else do we have? Nuclear physics. I did take. Did you take nuclear? I thought it was kind of useful because it's like a physics stoichiometry in some sense because you're looking at like how energy initial and energy final states and the kind of decay, the decays and the different ways that radiation happened and whatnot. And also you can get into Feynman diagrams. I think I didn't really get super deep into Feynman diagrams during my nuclear course, but it was pretty cool. I think I learned some interesting things. Wouldn't say highly useful, but it was kind of useful.
Yeah, I think for a theoretical physicist, yeah, it's kind of sucks because you do need to kind of learn all the physics.
I disagree with that as well.
If you're looking for a unifying, if you want to be the ultimate, like,
yeah, but I think you can learn a lot of this stuff on your own. I think we're a little bit. I think taking courses is a little bit oversold.
Oh, that's what he would agree with you.
Yeah, okay.
Because he's saying you can study this independently.
Yeah,
and he puts resources up.
Yeah, I think taking the core courses is really the most bang for your buck. And I think taking these kind of ancillary courses, you should try to do those on your own as much as possible. Like try to maximize the time you take for the most useful stuff in school, and then learn kind of the extracurricular stuff on your own.
Yeah.
And I would say I kind of tend to gravitate towards jumping into actually doing things sooner than later. Like go into the lab and do research, actually do, simulations and stuff. And if you're a theorist, like I think that's much more vital to get real skills rather than just taking 1,000 courses and then just taking all these little things that kind of give you a minuscule jump. It's kind of I follow the Pareto principle. 20% of the effort for 80% of the return. So I try to cut away all the fat as much as possible.
Yeah, I love the Pareto. I've heard it both ways, but
yeah, whatever.
I love that man finally made being somewhat lazy sound
cool or sound intelligent.
Yes, 20% of energy for 80. Big brain shit.
I'm not lazy. I'm a Pareto man.
I'm the modern man, as everyone should aspire to be.
Right.
Yeah. He says you should also. Damn, this is way too much.
List. Some of these things I don't even know what the hell it is.
He says, yeah, advanced quantum mechanics. I mean,
do we need a whole?
As if it's not already advanced. No, he says you should study advanced quantum mechanics, which kind of gets into like concepts of like interpretations of quantum mechanics, Bell's inequality, what that means.
Yeah, I think if you can take quantum mechanics as far as you can, that's always useful.
Honestly, yeah, I think I would agree with you.
Quantum mechanics is just super useful.
Because you can get really deep into quantum stuff and then pick up a lot of tricks along the way.
Yeah. If you can go as far as you can in quantum, I think that's a good use of time, honestly.
And quantum is one of these subjects that is like, I've said it multiple times, but even if you have no concept of even classical mechanics, you can kind of go into it just being like, I'm gonna go in and see what I find,
Mm-hmm.
because you kind of learn things along the way. And yeah, sure, you work with Hamiltonian, but it's a total energy. Like, you see the kinetic energy plus.
Yeah.
I mean, you need calculus if you're using Schrodinger's
Sure.
formulation, but there's also the matrix mechanics thing, which is linear algebra. So you can kind of get far on some more basic concepts.
Mm-hmm.
It's just the rigor comes when you see this stuff applied to boundary conditions. Like, I don't know, the first time I saw
Infinite square well.
not the infinite square well, the Dirac
Delta function.
I was like, what the hell?
Right.
What kind of function is this?
Right. It's one of those cool ones where you get excited to do it.
Yeah, and then you're like, what kind of function is this? And then you realize, oh, it's not a function.
Right.
This is why it's so
One of these
weird.
clever fucker problems. Yeah. Gives you respect for clever physicists.
Who made the? Oh, it was Dirac.
I was gonna say really one.
Who made the Dirac function?
I'm so out of it, man. This is hilarious. Yeah. Shout out to Dirac. I think he said that he felt dumb for calling it a function.
Oh, right.
Yeah.
Yeah, that would be something Dirac just looms over for just years of his life.
He's like, man, I feel so stupid. But that should make you feel somewhat like pat yourself on the back a little bit, because even the highest level guy called something a function that wasn't a function.
Right. I think that's technically a distribution, right?
Right. Yeah.
The Dirac distribution, if you want to be accurate.
Yeah.
I don't have any idea what the difference is, but that's what it is. I guess because they say functions can't be vertical, right? If you remember back from the days, like you can't have more than one point along the same an x value cannot return multiple y values.
It's a
to be
uniqueness.
function.
Yeah.
Something along those lines. I don't remember exactly.
Yeah, because a function would give you a different output, ideally, and here you get you
get infinite number of outputs from your one x value.
Yeah, which is like, huh?
Whatever. Yeah.
But yeah. So a mathematician.
Math shit, I don't care.
So if Dirac ever set foot in the math department, they would beat him up.
Come out to play,
Yeah.
Dirac.
Yeah. It's a straight out of the Warriors.
Right.
But yeah, they say to also, or he's saying to also. I don't agree with this. Superstring theory and supersymmetry. Well, supersymmetry is fine, but superstring theory.
It's leading edge stuff. I definitely don't agree. I'm sure you can get some useful math and everything from it, but
it just depends on the route you're going, I think.
That's very specialized stuff. Definitely don't agree.
Yeah, all the
I don't know
fringe.
shit about superstring theory.
I would say like do it if you. I mean, I would say study all the fringe theory of everything's, all the fringe toes stuff.
Well, some stuff is probably not even worth your time.
That's what I'm saying. Like, be careful with like the theory of everything's. If you've already reached the highest levels, try to be weary about the toes out there.
Right.
Yeah.
And if you're already at the highest level, you already kind of know that because everybody's got their own half cockeyed fucking theory of everything. I mean, we've seen it already.
I mean, but who's, I don't know, because I remember reading some professor being upset that string theory was even kind of a thing because we lost a lot of great minds to string theory. It made it sound like a war, but
right. Well, it kind of is because they're competing for funding and also allocation of
resources.
Brains.
Yeah, true.
So it is kind of a war. Like, it is kind of a big deal when you have certain theories come about because there is a big movement towards certain theories, and the string theory was a huge one. You had, of course, the string daddy himself, Ed Witten, leading the charge. So that was a big
mind on that thing, and it kind of attracted a lot of the smartest people
during the time. And I think people have kind of lost a lot of faith in string theory, but, you know, I'm sure they got a lot of useful stuff in it, and it still may be right. Who knows? We just don't know yet. It's kind of one of these things where it's like, you know, we're still in our infancy of understanding what's the best theory of everything.
Mm-hmm. String Daddy, come on the show.
Yeah.
Plead your case. Plead your case, please.
Right. No, that's a Chad. If that's a Chad physicist of all Chads, it's definitely
Ed Whitten.
He kind of looks like Chad, the Chad guy. Now that I think about it.
We need to put a comparison on there.
Yeah.
And he does have like 15 kids, so you know he's a fuck machine too. So. Actually, I don't know if he really has 15 kids. I just see on his Twitter everybody's got the last name Whitten that he's following. I'm like, God damn, man, how many
kids do you got?
Damn, bro, he's fucking.
Let me see.
He's busting different kinds of strings, if you know what I mean. Anyway, quantum field theory.
Oh, he's only got 2 kids.
Okay,
Never mind.
quantum QFT. That's the one you really need to. That's the one you really need to kind of ingratiate yourself with. But there's people that say, "Oh, we kind of have QFT wrong," but I don't know. Like, who cares what they say? Just learn it.
I wouldn't say people say we got the QFT wrong.
Not wrong, but there's things that we're
incomplete.
missing. Yeah, incomplete.
Yeah, because QFT is like one of the most promising theories of all time, right?
Mm-hmm.
You can get literally like the fine structure constant to some crazy amount of digits. Like they have a bunch of corroborating evidence for it being real.
Right. But I'm saying like there's professors that I've heard say that it's like, oh, they still aren't comfortable with like certain things, like hand wavy things, because they're not as rigorous as.
Right, and there's also this thing I read that they say a sign that a theory is not really complete is when people don't know the best pedagogical way to actually write books on the subject. And it seems that that's the case with QFT. Like there's a shitload of literature out there, but people don't understand yet the best pedagogical approach to it. So you have a lot of different ways people approach the subject because there's no real optimized route yet.
Mm-hmm.
So if you want to get into QFT, that's really a great way to start, in my opinion, honestly. If you're like, you've got through all your core, you're a straight up real life physicist, and you're like, you know, I want to actually start contributing and do some real meaningful stuff in theory, QFT is a good way to go because it's still rife with things you can kind of clean up and fix here and there. And, you know, I think it's a good way to go.
Yeah.
And it's not like overshooting your bounds, you know. Going straight to string theory.
Yeah, I think QFT is probably the one that would benefit you the most in terms of returns, like being able to kind of be on par with professors.
Right. And like actually have new insights and things to say potentially. Would that be a smart one if you want to immediately become a contributing like theoretical physicist? Go through all your core and then end up at quantum field theory and you'll be extremely solid.
Yeah. And if you want to add the caveat of like if you're working in many particle systems, do quantum many-body. That's the other one. That's the more practically minded, but it's also pretty rigorous. Like you just deal with a lot of math that's accounting.
Mm-hmm.
You kind of learn how to do many particle systems, and it's tricky. But you'll be able to read pretty much any paper after that class.
Yeah.
Because like it's all modern concepts in physics.
Right.
So yeah, those two, once you reach that level, QFT or quantum many-body, you'll pretty much be able to read any paper in your field.
Yeah. I would say you are a straight up real full physicist at that point. Mm-hmm. Although I'd say you're still a real physicist after 4 years of undergraduate too. Yeah. But you know, if you get to QFT level, you're like a legitly.
You're at the
low high tier level.
You're at the professional level.
Yeah, you reached the minimal high tier, I think.
Yeah, because I would agree with Terrence. Like if you completed your bachelor's, you have more than enough to pick up a book and teach yourself.
Yeah.
From here on out,
and you can do actually contributing research and real stuff. Mm-hmm. It's just gonna be harder.
Right. You might not learn all the tricks.
Right.
You might not know all the math tricks or whatever.
Right. You won't know a lot, but you can do real things, and you have the scientific literacy to go all the way.
Mm-hmm.
But if you know QFT, you're like legitly, you're in the high tier game, at least.
Mm-hmm. So with that being said, would you add anything to this list?
To be a legit physicist, I would say, of course, for me, pedagogy is a big thing. Like, you have to know how to. I think I would like to see physicists more fleshed out in their understanding of things. Of course, it's not really true, because there's a lot of great physicists who really suck at teaching because they just kind of fly. I guess it's kind of different approaches, right? Because you've got kind of the Feynman approach, which is really good, high pedagogical, and then you've kind of got like who would be a good example? I guess maybe like the von Neumann approach, where you're very mathematical, and I think both work. Yeah, I guess I prefer, if you are pedagogical, you kind of have a really good intuition and grasp for concepts, and you really know the intricacies of a theory and whatnot. The kind of, if you're not interested in that, you could still go very far, but you're not really. I don't know if you really necessarily know as many details and understand the theory inside and out. You're kind of just, but that gives you a little bit of more room to just keep plowing forward, and actually just contributing and doing research. It's different approaches, I guess. What about you? Would you add anything to that?
Make sure to sleep in between that.
Yes. I mean, I know you people. A lot of you people think that you're so fucking badass and cool when you don't sleep. You're not cool. You're only just hurting yourself, because you're not a machine. You're not a Terminator. Relax. If you get sleep, that is like one of the ultimate hacks to being a good physicist and optimizing your brain. There are massive diminishing returns when you're tired, and they will catch up to you. So you're just going to do shitty work if you're staying up for like 15 or for 20 hours a day. It's just not.
Yeah,
smart.
Yeah, Gerard won't say it, but that's how the man lost his hair.
Dun dun dun.
He did physics too fast. That boy ain't right. He just did physics a little too fast.
Oof.
Nah, look, what he makes up at the top. What he makes up for at the top, he's got on his upper lip there.
Yeah, what he's lost in the top, yeah.
He's got a great mustache.
He does.
So respect. I respect the man, his credentials, and what he's doing. For the undergrads that want to propel themselves into physics, like if you're an aspiring physicist, go on this website. It's just look up How to Become a Good Theoretical Physicist by Gerard, Gerard, apostrophe T, and then Hooft, Hooft. And you will see his whole list, and he's got some resources on there. But I would say there's some books out there in terms of if you're teaching yourself a lot of this stuff, and if you're a physicist, you'll probably be learning stuff on your
constantly.
own.
Yeah.
So the way I've done research is go to physics. What is it called? Physics forums. The physics forum.
Oh yeah, called? That's an old classic. Physics forums.
Was it physics forums?
The ones where you would ask questions.
Yeah, but there was also another page where you ask questions. It's the physics page, not physics.
Stack Exchange.
Stack Exchange.
Okay.
Thank you.
Yeah.
Stack Exchange has great resources. Like if you ask people questions, like what's the best book to learn, people have like a resource list, and
right. So I want to find something like that. I just Google like top books in, let's say, quantum field theory.
Yes.
And then put Stack Exchange in Google, and there's always amazing answers on Stack Exchange.
Yeah. So do that. Like I know that this professor already put a list of books, but you need to recognize that you might not have the same learning styles or learning approaches that especially professors. Professors are already kind of of certain breed, so you need to kind of make that distinction for yourself. Be like, I really learn better if it's more of a conceptual approach first, and then get the applications, or vice versa, right? Like if you're more of like, I need to see the applications before I get to the really big concept stuff. Like
Right. Part of becoming a good physicist, in my opinion, is knowing yourself and how you actually learn. Because you will not be the same as anyone else, really. Like, you're always going to be your own unique version. So you really have to understand how you learn. Like, don't feel bad because you don't learn exactly like this person. They're optimized for themselves. And that's the beauty of physics also, is because you have so many different perspectives, and they're like these high-level people that think in these different particular ways. But you need to really understand how you think, because it is going to be unique to yourself.
Yeah.
And the only way you're going to understand that is actually doing problems and doing the research and doing the work, because you won't know unless you do it.
Yeah. Pretty much.
How are we looking on time, Juan?
Oh, we should probably wrap up soon. But yeah, I mean, yeah, look up books on that. Look at Amazon. Amazon also has some decent reviews, but I wouldn't rely on it too much, just because it's
Stack Exchange is better.
Stack Exchange is better.
Yeah.
So
go to the heart of where real physicists are at.
Yeah. And I don't know. I don't necessarily agree with professors who say do all the problems in the book.
I think it will work though.
It would, but I would say do all the problems that are interesting to you. Like, because if those are interesting to you, you'll really be invested in it.
Right. Yeah, I agree with that.
Because there were definitely, I mean, if you see a hard problem, like, don't give up on it. Try to figure it out, but also recognize that problems are typically made by professors, and this is why I like solid state physics, because these are real life problems that they kind of put into physics.
Right. There's like an application to it. Yeah, those problems are really nice when you actually kind of understand the real setup or what's really going on.
Because a lot of you'll see this with the what is it called? The elective courses like solid state physics, where they will put a question from like some research that was a research paper maybe 30, 40 years ago.
Right.
It's like, oh,
it's solved now.
Yeah, but it's solved now, and now it's condensed into packaged into a question in a textbook that you can solve. But it was a problem that was a legitimate research problem.
So it's very useful because you're also collecting like this history of knowledge as well. So you kind of are getting, not only are you solving these problems on your own, you're kind of also getting confidence in actually being able to solve new problems yourself, because you're understanding kind of the techniques and how you're supposed to do these things.
Yeah. And and I would be weary. This is why I'm saying, like, try to avoid doing all the problems, because some problems are just like the professor who wrote the book. Maybe if they're going for volume, sometimes sheer volume of problems, like you'll see that sometimes. Some of them problems are just bullshit, like or sort of repeat conceptual stuff.
Right.
So
they'll change a number, and you're like, "Oh, come on, man."
Yeah. Just like, I'm wasting my time here.
Yeah.
So,
but some changes are actually legit, where you might think it's like a repeat problem, but then it's like one little change could throw you off if you don't really understand. So you should try to do those problems.
Yeah.
That might seem like they're bullshit, like switch one thing around, but sometimes it can fuck up your whole reasoning.
Yeah, the problems that really, really, really do it for me are the ones that kind of have it helps me really understand it deeper. Like, there's a bigger, it's like cracking an egg open and then getting like two little yolks in there. You know what I'm saying? It's like, oh, okay, I have two for the price of one. That's not
right.
Those are the big conceptual problems that you're just like, when you finish it, you're like, wow, I learned a lot from this.
Right.
But there definitely have been problems where I'm like, I barely, I got 5%.
There's no yolk. You're like, where the fuck is
this was just busy work. Why am I doing this?
Yeah.
So
Kleps Gordon looking at you.
I'm saying be discerning. Be somewhat discerning when you're doing problems, because time is of the essence. Like, if you really want to be a good physicist, you need to really try to move through things pretty quickly.
Yeah.
So,
of course, work at your own pace, though. No rush.
Yeah. But I'm saying, like, if you really want to get to the highest levels as soon as you can, focus on that. But
yeah, sounds legit.
Yeah.
Now, with that said, I guess we can wrap up, since the garbage truck is fucking up our audio.
But yeah, anyway, folks, make sure to like, share, comment, and subscribe.
Check out the websites, Eigenbros.com, Eigenbros on Twitter, Eigenbros on Instagram, Eigenbros2 on TikTok. We updated the website as well, guys, so make sure you check that out. Looks a little bit more fancy.
WordPress is fucking up on me, though, a little bit, so
it's a little bit annoying. I'm trying to fix it a little bit, but it still should be up.
Yeah.
And, of course, then, patrons, guys, thank you guys again. We greatly appreciate it. If you guys want to join our Patreon, it's patreon.com/Eigenbros. And, just donate $1. You can get all the access.
Seriously.
Yeah.
Yeah.
So support your boys if you can.
Please do.
And I think that's it, Juan.
I think that's
Is
it,
that
folks. Yeah, yeah. Stay tuned for next week.
Signing off.
Peace.